2 more problems to go. I just made a bit of adjustments. Number 6, if I look at the following problem, and you notice they're making those simple just so that you get used to this. And here, since those are 0, I know I'm going to get s squared, but be careful, that's not always the case, plus 4f of s, and by 17, this is twice, and if you apply the Laplace on that, that is e to the negative pi over 4. You know what I mean, right? Over 4s, that is by 17. Got it. Now, if I factor an s squared out, actually if I factor an f out, which is the function, that is, you know what, let me not skip steps. That will be s squared plus 4 equal 2e to the negative pi over 4s, and f of s will simply be 2, maybe I should write it this way, e to the negative pi over 4s times 2 over s squared plus 4. And now this is straightforward. If I apply the inverse Laplace transform on this, I will get, you know what, to save space and make this look more efficient, I will get f of t to equal, and let's see how this works. This matches property number 5, if I'm not mistaken, identically. 5, yeah, 4 and 2, perfect. So this should give me really just a sine of twice t, but since I have this function up front, this is going to pick up a u sub pi over 4 of t, and that's going to make it t minus pi over 4. And that would be the solution, and that's pretty much it. And you could see how useful this is and how quickly I could solve a differential equation by using this table instead of me using integrals or any alternative. Of course, those are very specific problems, you know. If this was to solve everything, they wouldn't have taught you the rest. We want to do number 8, and you notice number 8 is a 4th order linear differential equation. Well, if I jump straight at it, but again, they gave us the same deal. They gave us all of these to be 0 for simplicity. If I apply the Laplace on this, I will get automatically s to the 4th times f of s. It should be minus s cubed times y, s squared times y prime of 0, s and y triple prime, but they're all 0, minus, and that's simply f of s. And on the right hand side, I'm going to get e, and since that's shifted, that's simply negative s. And if I factor f of s out, so tempted to skip steps, there's no point in doing that, minus 1 e to the negative s. So f of s is actually e to the negative s over s squared minus 1 into s squared plus 1, s minus 1, s plus 1, s squared plus 1. So basically, the problem again is down to how quickly I can figure out where does 1 over s minus 1, s plus 1 into s squared into s squared plus 1 come from? Well, that is a over s minus 1 plus b over s plus 1 plus over s squared plus 1, that is cs plus d. I could figure out a and b in no time if I clear the fractions. And I could say this is cs plus d times, if you multiply those, wouldn't that be s squared minus 1 or s minus 1 into s plus 1, it makes no difference. And now I could find a in no time. And how is that? Let s equal 1. I'll get 1 to equal a times 1 plus 1 is 2, and 1 plus 1 is 2. A 1 in there will make that a 0, and a 1 in there will make that 0. That means a is actually 1/4. If I let s equal -1, I will be looking at 1 equaling a -1 right there, that's a 0. B, -1 minus 1, that's a -2. -1 plus 1 is a 2. And a -1 right there, that's a 0. That's negative. So B is actually -1/4. I got A and B. This is 1/4, and this is -1/4. So I could say 1/4 right there, and -1/4 right there. Now the beauty of this, if I let s equal 0, I could say 1 equal 1/4, a 0, 1 times 1, minus 1/4, which is b, times -1 times 1, a 0 there, and a there. And here if I put a 0, and a 0, I'll get a d into -1 times 1. So this is 1 equal 1/4 plus 1/4 minus d. That means this is 1/2. That means negative d equals 1/2. So d is -1/2. And now to find the last one, of course I could use the Book's method. I could let s be anything other than 1, -1, and 0. How about if I let s equal 2? I will get on the left hand side a 1 equaling a 1/4 into 3, 2, 4, that's a 5 if I'm not mistaken, minus 1/4 times, if I put a 2 right there, that's a 1, and that's a 5, and I'll get, oh wait, I'm running out of space again, okay, and I'll get c times s is a 2, plus d, and we got d to be 1/2, and that's going to be multiplied by a 2 plus 1, which is 1, and a 2 plus 1, which is 3. And now you just want to solve this. Of course, you could use systems of equations if you want. 1 equals, this is 15 over 4 minus 5 over 4. This is 3 plus 6c minus 3/2. LCD is a 4. 4 equal 15 minus 5 plus 24c minus 2 times it's a 6. So I'm looking at 4 equal, if I take 15 minus 11, that's a 4. That means c is 0. So I got this c to be 0. So let me see how this plays out. I could say f of s equals e to the negative s, I'm going to leave out. That is, I'm going to take a 4 out. That makes this 1 over s minus 1 minus 1 over s plus 1 minus 2 over s squared plus 1. And now if I apply the inverse Laplace transform on this, pretty much I'm done with the problem. If I take the inverse Laplace transform, I will get the solution, which is f of t equaling over 4. This is going to pick a u sub 1t, and this should be e to the t. This is by 2. But instead of t, I'm going to shift it by 1 unit, t minus 1. minus, this should be e to the negative t by 2 again. Let me make sure it is 2. It is by 2. Opposites. So that should be by 2 again. E to the negative t, but instead of t, it's going to be t minus 1, always because of that. And here I get to this. I'm going to take a 2 out. This is 1 over s squared plus 1. That's a sign. That should be the sign of t, but then again, I'm going to shift everything by 1. That's the price that you have to pay. And this is by 5, if I'm not mistaken. 5 it is. So make sure on the homework you practice writing this, because on the exam, I might let it slide on the homework, but there's no way I would let it slide on the exam. I have to see these numbers. That table you already have uploaded in Canvas, and you could use it on the exam. Of course, you're not going to memorize that. Make sure you have it handy as you do the homework, and the homework is simply those 3 problems, 1, 3, and 7.